Hello. I'm going to ask a question. What is 1 minus 0.999 and so on in infinite? That is like what is this equal to? I'm going to claim this is equal to 0. And to get an intuitive idea about it, we could think about this as being 1 minus 0.9 minus 0.09 minus 0.009 minus and so on in infinite. And if we first take this part, then we have 1 minus 0.9, which equal 0.1. So this here is 0.1. Then we could take that part in step 2 and take 0.1 minus 0.09, and that's equal 0.01. And then we take the next one, 3, 0.01 minus 0.009, and that's equal 0.001. And then we can continue doing this. And we will end up with a number like 0.0000, and then a lot of zeros ending with a 1. And if we do this infinite, there will be an infinite series of zeros, which tells us that it should be 0. But you may think that, yeah, but you know, there is this little 1 there in the end. There is a rest. Even if you go to infinite long, there is still, like, you know, a little small tiny m out there. But it isn't, and I'm going to prove that for you now. And how we prove this is to assume, okay, let's assume there is a little rest number there in the end, a little 1. That means that 1 should be equal 0.999 plus that tiny little number. We call that x. So how tiny is that? Well, we have to solve this equation here. So 1 should be equal this. And how we could start here is by multiplying both sides by 10. So we have 10 times 1 equal 10 times 0.999 plus x. And this is, of course, 10 equal 9.999 plus 10x. Then what we can do is we could subtract 9 from each side. So we have 10 minus 9 equal 9.999 minus 9 plus 10x. And this is 1 equal 0.999 plus 10x. But hold on now. So we start with 1 is equal 0.999 plus x. And now we end up with 1 equal 0.999 plus 10x. In other words, we are saying 0.999 plus x is equal 0.999 plus 10x. And here we could remove this number here by just subtracting it, and we get x equal 10x. Now, we gone from here to here. This means that that number here could be 10 times higher, and that doesn't make sense. And this is what this equation says. This number can be 10 times higher. The only way for this to make sense is that x is 0. But this is still an equation, which, first of all, it doesn't make that. We know it has to be 0, but how could we prove it? Well, in math, we are not allowed. No, we are allowed to take 0 and divide it by any number a. This is allowed. This is okay. But we can't take any number and divide it by 0, because this is undefined. Because like if we divide, we could get rid of the x here by dividing by x on both sides. So x equal 10x. If we divide by x on each side, x divided by x equal 10x divided by x, then we get 1 equal 10, which is not true, and which is why a division by 0 is not allowed. But you could say we still haven't proved that it's 0, and that's true. We just proved that we end up with incorrect result. The way to handle this equation, to solve what x is to say that x equal, x equal to 10x is by saying, like, we subtract an x here, and we subtract an x from this side, and then we get 0 is equal 9x. And if you remember, we are allowed to divide 0 by any numbers. That's okay to do. So we could divide by 9 on both sides. 9x through 9. And this thing here is always equal 0. Because if you take nothing and divide it by anything, you still ends up with nothing. And this here, the 9 cancel out each other. And that shows that x is 0. That's a proof. That's a proof that there is no rest. There is no extra ammo there. They are the same. If you're still not convinced, we could think about it like this. Any number divided by itself is equal 1. So, for instance, this is equal 3 through 3. And that's just another way to say that 1 plus 2 divided by 3. And this expression can be written 1 over 3 plus 2 over 3. This thing here is equal 1/3, 0.333, plus this thing here is equal 0.666. So there is lots of 3's there and lots of 6 there. And this thing, if we sum them up, we got 0.999. But we started with 1 and we ends up with 0.9911. We start with 1 and ends up with 0.999. Is an equal sign. This is also a proof. So how can we understand this? This is a little bit strange. How could two different numbers be the same? Well, there is different ways to think about it. One way to think about it is that this is just another name. This is just another name for this. That is to say that you have something here which is either called 1 or it's called 0.999. This is just a name for it, for that entity. And that's one way. The other way is to say that if you think of numbers on a line like this, so here we have 0, and somewhere here we have 1, and then we have 2, and then we have 3, and then we have 4, and in between here we have 1.5, here is 0.5, and here we have 0.75. What I'm saying is that we have a lot of numbers on a scale here, and there is lots of them in between here. And what we can ask is like how big is the gap between these two numbers. So for instance, between 2 and 3, the gap is 3 minus 2 equal 1. Yeah, okay. And what's the gap between 2 and 2.5? Well, that gap there is of course 0.5. Huh? Basically what that question is like we're asking how densely packed are numbers in between each other. And what we can say here, if we look at 0 here, 0, and then we kind of like zooming in to the number, no, it was 1 here, and then we kind of zooming in that region here hugely. We go very close to it, and here we have the number 1, and here we have the number 2999111, and the question we ask is like what's the distance between these two numbers here? And this equation here says that distance is 0. So here is something and here is something, but the distance between them is 0. Right? There's another thing to think about. So we have two different things, but if we put them on a line, they will occupy the same spot on that line. That is to say, it's very densely packed. Which way you choose to think about it, there is nothing to say that this is right or wrong, but it is a way to think about numbers, either as a different name for the same entity, or that they are very closely packed. Or so on this line here, when they are so closely packed that they occupy the same space, what we say is like this is a continuum. There is no breaks in it. But notice 0.9 here is made up of this is integer numbers, and you may think, well, I'm going to talk about that later, but the thing I'm saying, like the thing I want to say is that okay, that seems to be very dense, but I could tell you that when you're working with integers only, even though numbers are very densely packed, so they overlap each other, there are still gaps. And that's something to think about. That how could that be? There is an answer to that, but I'm not going to talk about it now, but end it here.